Good afternoon, everyone. Welcome to my presentation, distribution of tree coverage in Mountainside, New Jersey, and how temperatures are affected by it. So first off, I'd like to give a little bit of a background. Mountainside is a suburban town, 30 minutes outside New York City and 30 minutes away from Rutgers University. It hosts a population of around 7,000 people. It's 4 square miles, has a lot of forest area, and lots of ponds, lakes, and rivers. It borders Watchung Reservation, which is this 3 mile square radius of forest. And thanks to tree coverage, rarely are homes damaged from weather or direct sunlight or from flooding. It holds a strong historic presence with some of the oldest homes in New Jersey. Uh, some examples are the abandoned village, which is right on the border of Mountainside, Berkeley Heights, and Watchung Reservation. It's actually a tourist attraction. You can go into the forest and actually look at them. This is one example of one of the homes in the abandoned village. Uh, Two other places, the Levi Corey House and the Hetfield House, they're also some of the oldest homes in New Jersey, and they're in Mountainside and on the border of Westfield. This is the Levi Corey House, which they ended up moving in 2012. It was preserved so well they're able to move it actually down the street to a place because they're going to build a strip mall. So, the importance of tree coverage, as you can see, you have the suburban area along Route 22 and the Watchung Reservation, which expands all the way into Summit, Berkeley Heights, and even Watchung. And it's this massive forest. It almost looks like only green space. And the mountainside's known for its host various populations of different animals, so a strong biodiversity, and protects environments, urban areas from UV light. As you can see, all of the trees create this massive canopy, which obviously protects from solar uh, energy. And this also protects homes in mountainside where there's more tree coverage from damage from the sun, like fading on roofs or even just wearing down houses. It also helps with health benefits. Less people die every year due to heat stroke because it's cooler temperatures by up to 5 degrees. And the reservation spans over 3 square miles at 600-foot elevation. So mass amount of trees and tree coverage within a very small vicinity, and an excess in trees within such a small radius allows for cooler temperatures. Uh, Cooler temperatures provide shelter for certain species and wildlife, also provides a better environment for hikers who live in the surrounding areas. Uh, my methods of data, how I constructed my map in order to understand which areas of mountainside had the most tree coverage and which areas benefited the most. I created a point density map. Point density map is a thematic map which uses points within a radius to produce a visualization of density. So, firstly, I found a suburban area within mountainside along the Watchung Reservation with no development, no industrial buildings similar to that along Route 22. And this is a perfect 1 to 1500 scale image where I worked with due to you having the forest right here, you have some urban area, and then you have a little bit of area with trees. So you can see the small vicinity of trees, how that can benefit this little area compared to this. And then comparing all of that to the reservation, what's to begin with the reservation. So uh, firstly, in ArcGIS, I define my projection as my current map under the default coordinate system, which is WGS 1984 Mercator. After running the defined projection, I clicked analysis tools. I then created my feature data set, which I named editing features. Then I created my feature class trees with a geometric type set to point. And then I did not download data off of a government site. It was actually a big enough scale where I was able to plot the trees by hand and felt that that would pretty much prove my point as is. So once I created my pointing system, I manually plotted each tree within a 1 to 1500 scale vicinity. I changed the symbology to something bright so you can see it through the trees. And you can see visually how all of the points are gathered in a cluster along the forest and begin to spread out as these little forest dispersions throughout the urban area. You can see some streets barely have any trees. So in creating my point density map, uh, I assured myself that the selections were clear first, and then I went to analysis tools, uh, clicked on point density and geoprocessing. Under point density, I clicked parameters. I then set trees as my input point features, set population field to none. Uh, Output raster is just the name of it pretty much. I changed my output cell size to 2, and then neighborhood set to circle, radius 50 meters, and then changed area units to square meters. Uh, so this would give me a good proper radius spread for my density map, where it would pretty much show similar to like a weather map of how these points cluster. Um, I then clicked on point density, symbology. I changed the symbology to classify, made it 8 classes with under manual interval, and I kept the purple gradient color scheme that it gave me. And I made adjustments to the label as such. As you can see, no trees uh, within this radius, 5+ trees, 10+ trees. You don't really see those on the map, but here, as you can see, the more trees within a given area, a given radius, uh, the darker the purple gets. Obviously, 100+ trees within the 50 square meter radius can be seen right here along the reservation. So these are my findings, and this is the map I created. After adding point density, a visualization of the amount of coverage was apparent. On the left portion of the map, Watchung Reservation, there's plenty more tree coverage compared to the local suburbs of Mountainside. As you can see, there's around 25+ trees, maybe 50, given this massive area. Uh, and that's within 250 to 1,000 feet. So obviously there's a larger distribution of trees compared to the Watchung Reservation. And as you can see in the map, the closer vicinity of these trees within this 50 square meter radius, the cooler the temperature. So that's actually what the map is showing. This darker area not only shows the amount of trees within a smaller vicinity and more area, it also shows the cooler temperatures, which can help with biodiversity, which is creating habitats for wildlife. It cools the air around the trees due to evapotranspiration, which is a process where trees turn um, push water vapor out into the air and ultimately cools the air around the trees. And then ultimately you have the tree canopy, which is the largest point of the tree, covers most of the land, and this is what causes shadows and creates shading. And what this does is this is another reason to how it cools the area around. So uh you have better air quality due to less CO2, which also contains more heat. You have tree coverage, actual canopy, which also reduces sun heat. And then you have uh evapotranspiration, which actually pushes water vapor out into the air. So you have all these uh uh reasons of how the tree is affected and what the tree does in that given environment, and it all promotes cooling the temperatures around this area and right here. Um, what can be interpreted when comparing tree coverage and mountainside with a current temperature map, This is as of December 8th, 2023, from Weather Channel. I actually took this from day of when I was working on this project. Uh, and as you can see, when you line up both maps, it's almost exactly the same. Right here you have Mountainside and the Watchung Reservation, coincidentally the same color. But as you can see, the more into the forest, the cooler the temperature is by about 5 degrees, which is what was predicted pretty much. And this is due to the tree coverage and the better air quality around the trees, creating lower temperatures. And yeah, so in comparing both these maps, it's pretty much confirmed that my findings correlate with that of temperature readings. Yeah, so why is this important? This is important because it allows urban planning and policymakers to understand something that's so cheap yet very practical in urban environments. And it one tree alone can help so much at lowering temperatures. And it just proves that the like electric cars and all this is too expensive. And this is probably the most practical solution to the uh, climate change and the heating of these towns getting more hot. Um, as you can see, this also helps houses too during the summer. So not only are people, um, some people just not survive. People are surviving from heat stroke due to lower temperatures. There's also less skin cancer. Uh, there is less energy being consumed due to uh, trees providing shading and cooling, so people aren't using air conditioners as often. So I believe it's very important in urban areas to eliminate deforestation and, if anything, promote growing more trees, because this can clearly solve almost all urban challenges. And it's so simple because it's just nature's architect. It's already there. All we have to do is plant trees, which is very cheap as well. So yeah, I hope in the future going on, people will begin to plant trees. Towns will take on this initiative with this data. And yeah, thank you all for watching.